Checks. Data plane checks. In this module, we will understand how the data plane works, in the case of a single SD-WAN CPE deployment and a high availability deployment. Single CPE deployment, data plane verification. This output shows a single appliance branch, with 2 transports, MPLS, and Internet, and 1 LAN segment. We will check the data plane functionality by sending traffic from a host on the local LAN, 10.10.40.0/24, to a host on the remote branch having the subnet 10.10.20.0/24, that is, the LAN on the hub site, D3 Hub 1. The show interfaces brief command will display the IP address, and the VRF names of the respective interfaces. Now, we will not check the routing table on the LAN, as we already done this during the control plane checks. Instead, we'll now check the forwarding table on the LAN VR for the LAN IP segment of the remote branch. Here it is 10.10.10.0. We see that the next hop is pointed to 10.1.224.102, which is the management IP at the hub 1. Traffic is going via the encrypted tunnel DTVI 0/36. And, next, by verifying the dynamic tunnels, using the command show interfaces dynamic tunnels, we see that the DTVI 0/36 is towards hub 1. Now, we will initiate traffic from the LAN segment on SD-WAN branch, spoke 2 towards the LAN segment on SD-WAN branch, hub 1, as we observe from the output above. When an ICMP session is initiated between the 2 branches, the session takes the MPLS transport. At this point, the encrypted tunnel between the branches is also up. And, when the active transport fails, the ICMP session continues over the other available transport link in the branch, in this case, Internet transport. Important thing to note here is the forwarding table. It remains unmodified. Note the aging of the tunnel in the forwarding table. We see that the encrypted tunnel between the 2 SD-WAN branches, spoke 2, and hub 1, does not go down even if the MPLS transport link fails. This is an important test to be done, once the appliance is onboarded. High availability deployment, data plane verification. When a workflow template is created for a redundant CPE deployment, the device template is created with a transport VR for every WAN interface present in the pair, even if the WAN connection is not directly connected to the device. A .1Q subinterface, with a /30 private address range is created on the cross-connect link for each transport VR. So if we look at our deployment schematic, we have MPLS transport VR on primary CPE, and Internet transport VR on the secondary CPE. The redundant CPE workflow automatically creates the subinterfaces, and inserts a default route for the transport VR which is not present locally in the CPE. So, in effect, we get the Internet transport VR extended to primary CPE, and MPLS transport VR extended to the secondary CPE. Source NAT is performed on the paired device subinterface. In Versa, the cross-connect uses the IP range 172.16.255.0/30. The output shows the interface configuration of a branch deployed in high availability configuration. There are 2 VLANs on VNI 0/2, VLAN 1, and VLAN 2. Here, on this CPE, we have only one upstream transport VR, that is MPLS transport VR, and the corresponding interface is VNI 0/0.105. To get access to the paired router's upstream transport VR, the Internet transport VR, a tagged subinterface VNI 0/2.2, with VLAN ID 2 is configured on the cross-connect and associated with the respective transport VR. VNI 0/2.1, with VLAN ID 1, is configured with that of the local upstream transport VR. This is to extend this transport VR to the peer appliance. A similar configuration is present on the peer device. To verify the default route to the transport VR in the peer device, in this case, Internet transport VR, we can execute the show route routing instance Internet transport VR command. We observe that a static default route is pointed to the peer IP over VLAN ID 2, on the subinterface VNI 0/2.2. Now that we have verified the default route, the next step is to check if the remote IP is reachable. If for some reason it is not, check if the VLANs are present in the VLAN database, and allowed in the intermediate switch if any. Ensure the VLANs used here are not tagged as native VLAN. Once reachability is confirmed, initiate traffic to the remote branch and verify if the sessions are coming up on the redundant transport link.